Okay, we're going to continue with probability here in practical applications. So first we're going to look at the probability of OR events and the probability of AND events. So before we look at the probability of them, let's just talk about what they are. An OR event is having A or B happen. So let's think about like an 8-sided die here, since they go to 8 in their numbers. And we'll say A happens if we land on 1 through 5, and B happens if we land on 4 through 8. Probably now A or B happening is all of those outcomes together, so that's 1 through 8. Now the probability of A or B happening, if it is an 8-sided die and there's 8 total possible outcomes, then that can be expressed with this equation right here. Probability of A union B. That's what, think of union is equal to OR. And we have probability of A plus the probability of B minus probability of A and B. This keeps you from double counting. So they say, notice that 4 and 5 are not listed twice in the A or B, because if you did, you would have probability of A is 5 over 8 and probability of B is 5 over 8. And you would have a probability greater than 1, which we know is not allowable. Now let's go on to AND events. These are when things are required to occur simultaneously, or probability of both things happening. It doesn't necessarily mean simultaneous, but given one outcome, yes, it would be simultaneous. So, for the same example, the probability of both happening is only possible when you have 4 and 5, because then you would have 4, because 4 and 5 are in set A and in set B. Notice that this is much smaller. There's only 2 outcomes versus the 8 outcomes in A or B. So it's a lot harder to have AND events occur than B events. And when you think AND, you're going to have intersection, probability of A and B is equal to the probability of A times the probability of B. Next up, we have complements. So if you think back to that dartboard example, and I divided the dartboard into 2 halves. So if I was to say the probability of having the right half hit with a dart, and let that right half be A, then the left half would have to be everything left over. And we know that that's half, and we know that 2 halves sum to 1. So think of complements, or A prime. Sometimes it's A to the little c. Those are going to be what's left over. Probability of an outcome and the outcome's complement always sum to 1. Let's work through their little example here. We have S equals 1 through 6, A equals 1 through 4, and S is our sample space in this. A is our outcome, or A is our event. Then the complement to our event A is 5 and 6. It's everything left in the sample space that can occur that is not part of A. So the probability of A occurring is 4 out of 6. Probability of A's complement is 2 out of 6, and we can double check that A and its complement sum to 1. Conditional probability. This is a little bit more difficult than it is. It can look straightforward, and it's not. So you just have to think about it a little bit more intuitively. So probability of A, this little line here means given B, is how we're going to think of conditional probability. So the formula is the probability of A given B is the probability of A and B occurring together divided by the probability of B. Conditional reduces the sample space, so it's going to make it even smaller. Now, if A and B can't occur together, then probability of A given B is equal to 0, because probability of A and B are 0, and who cares what the probability of B is. So if you have a die roll and you have the left, you have odds and evens, you can't have both occur together. If you roll the die, there is no probability of A and B. So probability of A given B would equal 0. There's no conditional probability on that. And they go with a similar example here. Let's just talk through this real quickly. Suppose we toss a one fair 6-sided die. Sample space is then 1 to 6. A is equal to 2 or 3. B is equal to 2, 4, or 6. To calculate probability of A given B, we count the number of outcomes, 2 or 3, in the sample space B equals 2, 4, 6. Then we divide that. So all that's just saying plug it into that same formula. We know probability of A and B is 1/6. Probability of B is equal to 3/6. And probability of A given B is equal to 1/3. Sorry, I know there's a lot of language to that and it's a little bit boring, but most of these, if you get the A and B and the A or B, then it's just following the formulas.